So we were talking about how hormones activate target cells. Now let's talk about how they are deactivated. So what causes these things to be removed? Hormones have a longer lasting effect than, say, neurologic activation of something, but they don't last forever. What causes their removal? Hormones can be deactivated by one of several methods. Some hormones respond to a degrading enzyme. So for example, epinephrine, which again we know better as adrenaline, there's a hormone in our bloodstream, an enzyme in our bloodstream that degrades that hormone and deactivates its effect. Many hormones, however, are eliminated by the kidneys, and they come out in the urine, sometimes in their active form, sometimes in a slightly degraded form if there's a degrading enzyme present, but a lot of them are eliminated in the kidneys, which is why testing the urine is a good way to check for various hormone levels. We know urine tests are used for all kinds of things, pregnancy tests, drug tests for, like we talked about in sports, to see what kinds of hormones people may be taking as performance-enhancing drugs. That's because a lot of them are eliminated by the kidneys as part of the urine. When we talk about the half-life of a hormone, we talk about the amount of time it takes for the levels of hormones to decrease by half. And this is a good indicator of how quickly the things are cleared from the system. As you can imagine, it varies quite a bit. Some hormones, like epinephrine, have a very short half-life, and so their effect is very short-lived. Other hormones have a very long half-life, and so when they're released from a gland, they can remain at active levels for quite a long time in the bloodstream. Hormones also have a varied time of onset. Some of them are really, really quickly. Some take hours in order for them to have an effect. But it depends on the type of hormone and the receptor complex too. When multiple hormones are present in the system, there can be different kinds of interactions. So these are the three basic ways that different hormones can interact with each other when they're both present in the system. There is permissiveness, which is where one hormone cannot exert its effect unless another hormone is present, right? Think of like in the movies when they're going to launch the nuclear weapons and both people need to put in their key and turn it at the same time before it'll happen, right? That's permissiveness. There's synergism, which is where you have two different hormones producing a similar effect on a target cell with the effect of amplifying them. So, for example, the hormone glucagon has the overall effect of increasing blood sugar levels, but one of the effects of epinephrine is that it also increases blood sugar levels. If both of those are present at the same time, you would have an amplification of that effect. Then there's antagonism, which is where they offset one another. Say we stick with epinephrine as the example. What effect does it have on blood sugar levels? Raises them. But if we had, say, insulin present in the body at the same time, its major effect is to decrease the levels, and they would have more of an offsetting effect. That's called antagonism. The first specific location that we're going to begin with is the pituitary gland and the hypothalamus. They work together. So remember, the hypothalamus is this neuroendocrine organ. And one of the major ways that it controls the action of the endocrine system is by controlling the pituitary gland. You might see sometimes the pituitary gland referred to as the master gland of the endocrine system, but that's not technically correct because its action is being controlled by the hypothalamus. It's the puppet master pulling the strings behind the scenes. Physically, the pituitary gland is divided into two lobes, the anterior lobe and the posterior lobe. You see up here that the pituitary gland is also sometimes called the hypophysis. The posterior pituitary is composed mainly of nerve tissue, and so we sometimes call this the neurohypophysis. The anterior pituitary is made up of glandular tissue, and so it's sometimes called the adenohypophysis. That prefix adeno or adeno, that means gland. So that's glandular tissue, that's neurologic tissue. And I want to fast forward to a picture that we have here of the pituitary gland and hypothalamus. So here's our hypothalamus right here. There's the pituitary, the anterior lobe, the posterior lobe. I said that the hypothalamus is controlling the action. This is made up of neurologic tissue, right? So neurons in the hypothalamus actually project their axons all the way down into the posterior pituitary. And at the ends of the axons, at the axon terminals where we're used to them releasing a neurotransmitter, these axons will be releasing hormones that diffuse into the bloodstream and are carried throughout the body. And so the hormones released from the posterior pituitary gland are actually created where? In the hypothalamus. They're actually created here. They travel down the length of the axon and then are released and diffused into the bloodstream. That's what they're describing right here. So the posterior pituitary gland is a downgrowth of those hypothalamic axons. They release that stuff from the axon terminal that goes around the body in the bloodstream as a hormone. There are only two hormones released in the posterior pituitary gland. They are oxytocin and antidiuretic hormone. So just two, but they're important. And they have an unusual mechanism. So created in the hypothalamus, but released from the posterior pituitary. The anterior pituitary, or adenohypophysis, is separate glandular tissue, but it's still being controlled by the hypothalamus. So remember when we talked about those hormonal axes? Hypothalamus, pituitary, and then some other endocrine gland, thyroid or testes or whatever, right? The hypothalamus produces hormones that in turn act on the anterior pituitary to make something else. Okay? So what the hypothalamus produces are releasing hormones and inhibiting hormones. So when we talk about hormones of the hypothalamus, they're usually going to end in RH or IH. They're acting directly on the anterior pituitary gland to cause either the release or inhibit the release of an anterior pituitary hormone. So we don't have time to list them all, or I shouldn't say we don't have time. We will see each of these releasing and inhibiting hormones crop up when we get to more specific ones later on. But for example, the anterior pituitary gland makes growth hormone, for example, right? So to control those levels, the hypothalamus can make growth hormone releasing hormone to stimulate the anterior pituitary to make growth hormone. And when it's time to shut it down or decrease the levels, our hypothalamus can make growth hormone inhibiting hormone that decreases the anterior pituitary's production of growth hormone. And they're showing that relationship here. Okay. So it produces these various hormones, which are then trafficked to the anterior pituitary and result in the release of others. Here are the hormones actually released from the anterior pituitary. We will talk about them individually, but you see growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone, and prolactin. All released from the anterior pituitary in response to releasing and inhibiting hormones from the hypothalamus. So when we talk about actions of specific hormones, let's begin with the posterior pituitary hormones. We see oxytocin and ADH. We'll begin with oxytocin. This has come up from time to time a little bit already, mostly in AP1, I think. But do you guys remember what the effects of oxytocin are?
Isn't it like a feel-good or bonding type?
Yeah, it can be. I like to divide the effects of oxytocin into two categories and talk about the physical effects and the psychological effects, because you see it can be used in as a neurotransmitter in the brain, so it does have mental effects too. Physically, it acts primarily as a smooth muscle contractor, especially in the uterus and the lactiferous ducts. So, it's responsible for labor contractions and milk ejection. Again, in the uterus and in the lactiferous ducts. The reason why this has come up already in AP1 is because this was an example we gave for a positive feedback loop. Uterine contractions during childbirth. So it can result in uterine contractions that aid in childbirth, and then of course milk ejection too, associated with the same thing. But oxytocin, it would seem, from those two examples, would be limited to pregnant and nursing mothers, but that is not the case. Everyone has oxytocin, not just pregnant and nursing mothers, but everybody, including males and everything else. And that's because it also has psychological effects. You mentioned it as a bonding hormone, right? So oxytocin acts in your brain to promote emotional bonding. And you can see how this could be tied into other things. So one of the primary examples that people give of this is that oxytocin gets released during and just after sexual activity, right? And that's, again, to help bond people together. We see this association with reproduction here, right? Bonding the two parents together emotionally and helping them stay together is a way to help ensure that this potential offspring has a greater chance with two parents contributing. And then, of course, a lot of people have probably heard, if you're interested in trying to initiate labor or promote the beginning of labor naturally, what's one of the things they recommend you do?
Sex.
Have sex, right? To initiate an oxytocin release and hopefully begin those uterine contractions, right? In those instances, so remember, when we're talking about the individual hormones, what are the three things I told you should try and keep in mind?
Where they originate.
Where they come from, what they
Where they
do,
go. Oh,
and what they're stimulated by. So oxytocin, that's coming from where?
the posterior picture.
Yeah, it's released from the posterior pituitary. Its effects are things like emotional bonding, milk ejection, uterine contraction. And its stimulus for release can probably be classified as neurological. So we talked about how sex causes the release of oxytocin, and it's from physical stimulation, right? And what else? During nursing, the milk ejection comes about as a result of the suckling, right, by the infant, and that's again physical stimulation, in that case of the nipple, resulting in the release of oxytocin and milk being ejected, okay? So all of those things. But oxytocin is not only limited to sexual and romantic relationships. Obviously you see mother and child on here, which promotes bonding between mother and infant, but it's also seen in all kinds of different contexts too. So oxytocin can bind any two people, or not even just people, together, right? You know, friends, other family members. I even read a study I liked a while ago that when you play with and pet your dog, both you and the dog are releasing oxytocin into your system. It makes you feel bonded. I love dogs, so I thought that was neat. So it is a wide range of bonding. The other posterior pituitary hormone is ADH, which stands for antidiuretic hormone. If a person is on a medication that can be described as a diuretic, what effect does that medication have on the person?
Does that increase their urinary output?
Yeah, it increases their urinary output. So if this is anti-diuretic hormone, what does it do?
Decreases?
Decrease your urinary output. So this is one of the major hormonal controls over water volume levels in our body, right? So when you are dehydrated, levels of ADH go up, and you produce smaller amounts of urine that is more concentrated so that you conserve water. It also stimulates thirst in your brain. When you're well hydrated, levels of ADH go down, and you produce larger amounts of urine that are more dilute. So this helps maintain water balance. Hormones are fickle and finicky. They can be offset or altered or just generally messed around with by lots of different things. And there is a common substance that inhibits the effect of ADH. Do you know what it is?
Alcohol?
Alcohol, right. Alcohol inhibits the effect of antidiuretic hormone. So when you drink alcohol, especially in large amounts, your body loses the ability to concentrate your urine with respect to your hydration level. And, results in large amounts of dilute urine rather than it being specific to whatever your water volume is at the time. And that's why they say that one of the major causes of a hangover is dehydration, because your body is not regulating its water levels very well. And one of the things that really helps with the hangover is Taco Bell, right?
Yeah, McDonald's.
Yeah,
French
put a couple
fries.
chalupas on it, you'll be good.
Exactly.
After we talk about these different hormones, when applicable, we're going to spend a little time talking about disorders that can apply to the various hormones. And with basically all of them, for the most part, it's either you're producing too much of it or too little of it for the various disorders. So here we're at homeostatic imbalances associated with ADH. Diabetes insipidus is underproduction of ADH, and then the second one here is overproduction. Okay. Now notice the name there, diabetes insipidus. Sounds like we're talking about diabetes, but this is totally unrelated to the type of diabetes that you're used to thinking about. Okay. This word, the first word, diabetes, what does that mean? Any ideas?
I'm guessing it means deficiency sometimes too.
It's not a deficiency per se.
I don't know.
It literally means a flow, but it's referring to excess urine production. We'll talk about why a little later on, but the other kind of diabetes you're maybe more used to hearing about results in excess urination too, as does this one. The kind of diabetes you're used to hearing about with insulin and blood sugar levels and Wilfred Brimley and all of that. Do you know the full name of that disorder? Diabetes blank.
Mellitus.
Yeah, diabetes mellitus, which is spelled like this. That word means honey. So that disorder literally means like honey flow or honey urine, because there is, and again we'll talk about the mechanisms of this later on in the chapter, but there is sugar in the urine. And in fact, that used to be how you tested for diabetes. Someone would have to taste it. And if it tasted sweet, that was the indication. Luckily, we have chemistry now, and we don't have to do that. Doesn't that seem like the lowest rung on the healthcare ladder?
That'd be like
Urine taster. Hi, I saw you're hiring a brain surgeon. I'd like to apply. Whoa, slow down there, Sparky. You got to start at the bottom and work your way up. You're our new urine taster. So this one here, diabetes insipidus, the insipidus part refers to like, literally meaning like empty, in this case implying flavorless. So their urine tastes like nothing. What's happening is you lack the ability to produce ADH. So you're always producing large amounts of urine that are very dilute, hence no flavor, because they're mostly water. So we were just talking earlier about how alcohol consumption inhibits ADH effect. So having diabetes insipidus would be like how you produce urine when you're drinking, only it's all the time, right? So as you can imagine, dehydration is a risk. You have to make sure that you maintain good hydration levels all the time, or risk damaging dehydration. The opposite is an overproduction of ADH, called syndrome of inappropriate ADH secretion. Pretty descriptive. Basically, you're producing this stuff that concentrates your urine all the time, regardless of hydration levels. So these people really have to limit their fluid intake because their body is always signaling that it's dehydrated. And if you drink too much water, you can cause yourself problems. Things like fluid retention, headache, disorientation, can throw off electrolyte levels. So, that's a problem. Now we'll move on to the anterior pituitary. Here are the hormones produced by the anterior pituitary. Growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone, and prolactin. We'll talk about each one individually. But I want to point something out on here that I think is going to help us moving forward. This word tropic, when we describe hormones as being tropic, what we're talking about is what they act on, the organ that they act on. Okay? So adrenocorticotropic hormone is going to act on another gland, specifically the adrenal cortex. Okay? We can also talk about certain hormones like these two here. They are called gonadotropins. So we again see that same suffix, meaning axon. These are hormones that act on the gonads, right? Okay, so that's what tropic or tropin means. And you see here, thyroid stimulating hormone is also known as thyrotropin because it stimulates the thyroid, exactly. Most of these are amino acid or protein-based hormones, meaning they're going to dissolve in the water of the blood plasma and activate cell membrane receptors, as opposed to our lipid-soluble hormones. But growth hormone does enter the cell, behaving more like a steroid hormone. You see here, these are tropic hormones, meaning they are going to regulate activity of other glands, as we just talked about. Gonadotropins, thyrotropins, all of that. Let's move on to some specific ones, beginning with growth hormone. So growth hormone, it sounds pretty simple. It stimulates growth of most body tissues. So when do you suppose levels of growth hormone tend to go up?
Puberty.
During puberty. Heard of people having a growth spurt? That's because what they really have is an increase in growth hormone production. It is, like all of the anterior pituitary hormones, it is regulated by the hypothalamus. So the hypothalamus can create growth hormone releasing hormone to increase production, or growth hormone inhibiting hormone to decrease production. Right, so this is all being regulated by the hypothalamus. It's going to stimulate growth of bones, it's going to stimulate growth of muscles, as well as organs and all kinds of different things. And during puberty, who, males or females, experiences the greatest rise in growth hormone levels? Males. So we grow to a higher average height, higher average muscle mass, all effects of the higher levels of growth hormone. But besides that, it's doing some interesting things to your metabolism too. So besides just growing you, there's some metabolic effects too. So it says here, increases blood levels of fatty acids, encourages use of fatty acids for fuel, and protein synthesis. Now this is atypical. We'll talk about this a little bit later on with glucagon, but most of the time our body has a preference for using glucose for fuel, right? And you only start to utilize fat when your glucose levels are too low and your body's got to resort to using fat instead. But the same hormone that encourages fat usage also encourages the breakdown of proteins for energy, except under the influence of growth hormone, where you have a preference for using fats for fuel as well as building protein at the same time. So think about what happens to a person's body during puberty, especially a male, since they have higher levels of this stuff. Maybe you have said or been told or heard someone say something along the lines of, oh, that's just baby fat. When you get your growth spurt, that'll go away, right? Have you guys ever heard something like that? When kids are chubby, we call it baby fat, and so it'll go away when you get your growth spurt. Well, often it does, and the reason why is because, as we said, that growth spurt's occurring because of growth hormone, which also has a preference for burning fat for fuel. and building muscle at the same time, which again spikes during puberty. I often think it would be nice to have a second puberty.
I was just gonna ask, can I take some of that?
Yeah, it's
experience?
like I could, you know, I could grow a couple more inches and be all right with that. You know, put on some muscle and get a little fat. That'd be okay. But it doesn't really work like that. The answer, can you take that, is yes. Is it legal? No. And would it be good? No, probably not. Especially at high levels. I've read some things about what they call anti-aging clinics and the like, trying to introduce growth hormone at sort of moderate or low levels to reduce the effects of aging and increase healing speed, and et cetera, et cetera. Jury's out on that, in my opinion. But people like to take this stuff as a performance-enhancing drug sometimes too, to cheat at sports, or just get swole without having to try that hard in the gym, right? And it does promote muscular development, but the thing is, a lot of people, you know, if they're doing that, they're probably not being real judicious about their dosages, right? They just want to get jacked. The problem with that is, and I think I've done the same spiel in AP1, but it's causing growth of, say, bones, right? But because if you're talking about an adult, they have no growth plates, the bones can't grow any longer, right? But do they still grow wider? Yeah. And you can get some facial deformities and stuff, but you can also have spinal stenosis as the opening for your spinal cord narrows. It's increasing the growth of internal organs. They call that organomegaly. The heart can narrow, so it's generally not a good idea. And in fact, you know, my general stance on these things is that hormones are not something that you want to fiddle around with too much. You know, it's a delicate balance as it is, susceptible to a lot of its own problems, and you start throwing things in the mix, it tends to throw stuff out of whack. Let's see, we talked about GHRH and GHIH. Let's talk about some disorders related to growth hormone levels. We are going to talk about when there's too much and when there's too little, but with growth hormone, it's also relevant to discuss when this disorder occurs, whether it's in childhood or in adulthood. So when there is an excess amount of growth hormone, we typically refer to that as gigantism. And if it occurs primarily during childhood, gigantism is usually what we call it, but then there's a specialized type of an onset of hypersecretion of growth hormone that begins in adulthood, and that is acromegaly. Sometimes people just release too much growth hormone throughout their whole lives, and we don't really know why. And you know, like I said, that's gigantism. People can grow to be really, really tall, just large in general. As compared to acromegaly, these people would be normally proportioned, but very tall. In acromegaly, we're talking specifically about excess growth hormone production in an adult. And in those cases, especially if you had normal levels during childhood and adolescence, if you get, say, a pituitary tumor later on in your life, you can begin producing excess amounts of growth hormone, and we'd see some of those things that we just talked about. Widening and thickening of bones is one of the most common things that people notice as you have this, you know, potentially pituitary tumor hyper-secreting growth hormone. We're going to see that a lot, that pituitary tumors can increase levels of certain hormones depending on what cell type is affected.